Uh, Hello everyone. Uh, Welcome to my stream. This is my first time live streaming, and this is my new YouTube channel. Uh, so um, I'll quickly give an introduction of myself. I'm Praveen Sanap. I've been a software developer for almost 10 years, and in this YouTube channel called Agent Engineering, I'll try to talk about how we can use agents to make software engineering better, right? So we'll try to discover this new engineering practices that I feel software engineer will have to shift to from the current practices, uh, uh, given the shift in the LLM's ability to uh, code. So, uh, so that is a quick introduction of the channel. I'll quickly jump on to what is the agenda for this live stream. So I've written a small blog uh, for it. So you can find it in agentengineering.dev. So this is my new website. I'll paste this link in the chat and pin it. Right. So I'll quickly go through the document. So I've written it in a form of a press release, right? A PR FAQ, right? So the press release says that we are in golden age of computing, and with LLMs becoming more capable of writing functioning code, we have to imagine a new class of applications, right? And these applications will be developed by agents, right? And not just humans. Software engineering, there will be a major shift, I feel, in software engineering profession. And from developers where they were initially mm, currently writing the application directly, to developer building and guiding agents that write the application for them, right? So the work of software engineer will slightly shift, and their expertise will become how to use the agents effectively, right, to do the work that they are doing, right? And this new discipline is what I'm calling agent engineering, and which is this site and this YouTube channel and this live streaming series is all about. uh, the an essential part of using this coding agent by developers, right? An important part of it is being able to use trust it, right? uh, so basically, if you use Claude code and you prompt it, so you see it work and show some work, right? Show uh, like what how it is thinking, right? But mostly it runs in a kind of a co-pilot mode where it does most of the work. You generally observe it, so there is a kind of trust element in it, right? And I believe that it is important for engineers to understand how this agent work internally in order to trust it more and use it effectively, right? So when the agent fails, you know why it fails, right? Did it fail it reasoning, or did it fail it in the agent framework code, or where exactly it failed, right? uh, and when it succeeds, you know why it succeeded, right? uh, which is why I feel the agent framework like Cloud Code or Codex or others, they should not be opaque, right? They should be transparent, something more like Gemini CLI, right? uh, So if you are interested in learning how these coding agents currently work, right, how they do their thing, and if you want to also build your own, this series is for you, right? Mm, so as part of this series, I will be live streaming the development from scratch in Go, right? So we will develop you can say a Claude code like uh, uh, service software from scratch, and it will all be in the live stream. I will try not to do any offline work so that uh, people can know what it is, and I will do it in Go, right? Initially, the agent that I'll build will integrate with frontier model, and that is how the agent will, try to keep its edge by using frontier model. Then uh, we'll progress as and when the open weight model gets better. We'll try to shift uh, to using open weight models. Yeah. So there are a lot of open weight model coming out from China. So we'll try to see how our agent works with that, right? And uh, so in that way, we will create a like a framework or a ecosystem where we can do end-to-end application development on our local without depending on a proprietary software or proprietary models, right? Uh, right. Yeah. And so the end goal of this is once we have the framework, we should be able to develop applications, right? So this can be any application like software engineering applications. Uh, so in this series, what I will try to do is you do dog fooding by the way of developing another application, which I'll talk about shortly. So this is the overall agenda of this live stream. Uh, Quickly, I'll go through a bunch of FAQs. So this will be a living document. As and when I get more questions, I'll update this document as well. But this is the first draft. So what is an agent framework when I say? So it is a set of libraries and services, evaluation tools, runtime, and also maybe UI, right? Components that make it possible to build, observe, and improve agents, right? And an agent is an instance of a process that perceives its environment and takes action, often through tools, to achieve a goal, right? Okay, there is a orphan T over here. I'm planning to stream every Sunday, 9 p.m. Singapore time, right? And I initially I'll start uh, streaming on YouTube, but then probably I'll try to uh, do on Twitch as well. The tech stack, as I mentioned, I will be using Golang as a programming language for the framework. What are the prerequisites that anyone needs to have to be able to follow along? A basic familiarity with Go will be good, right? But it's not a prerequisite. If you have experience with any programming language, you should be able to follow along. And I'll try my best to translate any of the concepts, Go concepts, into other languages. So these are the ones I know. I'll try to translate those concepts in these languages. If you're completely new, this will be a good learning experience to see how large-scale systems are built. So no deep learning knowledge is required. So uh, you can follow along without that. Mm. Uh, okay, so quickly, what will be the first few episode cover? So in the first episode, I'll try to set up the project. I'll write the core agent loop. I'll initially integrate with Claude and write simple tools to read file, right? So with this amount of uh, setup, what we can do is we can build an agent that can explore a project repository. Given a project, it can explore what files it has, what's the directory structure, and it can summarize it, right? Uh, so this is already a good start for an agent. So it's independently able to perceive its environment, right? Where it's getting spawned, and it tries to explore its environment by seeing what options it has, and it takes specific actions like reading a particular file and trying to get more context of where it is, and then and the action it does for now will be just summarizing. So this is what LLMs do quite well, so that should be fine. In the second episode, uh, I'll try to integrate with more models, ChatGPT, Gemini, right, and enhance the tool set, the file system tool set a little bit to search and write files as well. Uh, and then we can just test the model again against the same test, and we see whether it can correctly edit a file, right, to do some operations, right. Mm, yeah, and so this is just a high level overview of what I'm going to do first two episodes to keep the horizon short. Uh, in the long term, what I'm going to do is uh, like enhance this framework a bit more to uh, uh, add features like agent memory. So I think that piece is a bit difficult to get right. So we'll explore a couple of approaches there. And other than agent memory, we'll try to make the agents work more observable so that when the user of the agent, right, coding agent is using it, they can follow along clearly what it is doing, right? Uh, so observability will be a bit focused. So probably we'll create an UI for it so that the developer can observe. So that is kind of like a high level plan of future episodes. But for the first two, I'll keep the agenda small. Coming to uh, how we validate, how we are going to validate this agent, right? Whether it works or not, right? So other than reading some files and summarizing what will it be able to do. So any framework will not be effective unless we have a good use case, right? So to for that purpose, what I have selected is an dog fooding use case to create a chess learning app, right? uh, so meaning that we will develop an agent to develop a chess building app, right? And we can keep the chess learning app simple by uh, probably having a simple HTML JavaScript based application with if backend is required, we'll use Go. And the goal of that application would be to improve my chess rating. So I am the person I will be dog fooding it on. So I'll try to improve my chess rating from 1200 to 1500. So that is the goal I've set for this project. It's like a pseudo goal. So we should have some North Star to have some guidance for us uh, to do work that contribute something, right? So this is the thing that I'm latching it on, so that whatever we do, whatever decision we make in terms of uh, how effective its use case will be, right? A couple of last few FAQs. uh, uh, will we be using other coding agents to help us develop this framework? So initially, no, we will not use anything like Claude Code or Codex. So to build the agent framework itself, I'll try to build it from scratch just by programming it. I'll try to use maybe uh, uh, Chat GPT to come or Stack for a Stack Overflow, like checking some syntax or something. But we'll try to avoid the other uh, because in my experience, what tends to happen is with a lot of vibe coding with this agent, the kind of project we build is kind of become monstrous, and then you don't really want to approach it, right? Uh, and usually it's a throwaway project. This is my overall experience using this agent. So with our agent, we'll try to see how to get around that particular aspect, right? How we can make maintainable applications, right? Where developers who are using the agent to make can go and mm, it kind of makes sense to them, and they can maintain it further on after getting work done from agent, or uh, mm, it is comprehensible to them, right? So that is the aim we'll try to keep. So once our coding agent becomes mature, we'll try to use it to develop itself, right? But till then, we'll only develop a toy application like the chess learning app. The last question I'll address before I jump into live coding is, what about other open source agent framework, right? Why not use those, and why build your own, right? So it's true, there are open source ones. In contrast to Cloud Code and Codex, which is proprietary, there are open source agent framework like Gemini CLI, Google's ADK, Microsoft's agent framework, right, which are open source, right? But what I'm trying to do with this agentengineering.dev project is to discover these new engineering practices uh, that developers will have to come up with. Uh, so there is an element of discovery there, which will not come by directly using these tools, right? Uh, and I believe it will be best served by developing the framework ourselves from scratch. Yeah. So this is kind of an introduction for this stream. Uh, mm, cool. I think we can get started with. So since it is from scratch, I will create a new project. Let's call it agent framework. Open source build oops, building it will be public. Cool. Our repository is there. Okay. So in this repository, let me there. I'll use Golang for development. New window. Okay, so we have our repo. I'll quickly do a git init and add the git remote. So we are connected there, right? Right. So our agenda for today is set. So I'll create a file called roadmap.md, and I'll add what we'll discuss. We're going to do the first few streams here. Agent framework. map. So let me just create a to do for now. Okay. Looks good. Okay. Let's start with the development. So first we need to do go mod init, right? And agent engineering dot dev agent framework. So this is our go mod. Oh, go not found. Okay. Let me fix that. Go. Go is here. So much more. Okay. Go mod init. It will should have a go file. Okay. And let's start with the main.go. Simple. Let's just do print hello world to see whether it's working. Okay. So the first run is working. So this is what I meant by scratch. So we'll do all the low level work also on live stream. Okay. So so we have to do a couple of things first. First one being integrating with Claude's Go library to be able to talk to LLMs, right? So there are a couple of ways we can do it. We can just use HTTP and make HTTP requests, but I believe using a library is better. Later we will abstract this call over an interface, and then we will implement other implementations of LLMs that integrate with OpenAI's library and then Gemini's library, right? Yeah. So let's change this to agent. Let's just remove this. Actually, we don't need this. So our first thing is integrate with Claude, and the second thing is have an agent loop. Right. And third thing is have tool calls for file system. So this is broadly how our work for today looks like. Let's hope we can complete it in the 30 minutes, next 30 minutes, or we can see how we can push to the next stream. Right. Let's get started with this. If you go to Claude, go SDK and see client SDKs. So there is a Python one, TypeScript, Java, Go. Okay. There is Go SDK. This is an official Anthropic SDK. Okay. Let's get this thing. Go get. It should appear in our command file. Oh no, it won't appear unless we use it, right? Yeah. This is a sample. This is a sample of what it looked the integration looks like, right? What we're doing is creating a new client with API key, and then we are invoking and asking some basic question, pass the model. Okay, so let's just get this thing. Just to see if our integration is there. So I'll not bother with abstractions upfront. I'll just try to make something functional. Then we can refactor it to have better abstractions, right? This is working context. I don't know why they said to do. Let's change it to background. Right. Okay. For API key, what I'll do is I'll get it from the environment variable, right? So raw big API is okay. os.get and so currently I'm using GitHub Copilot auto completion, so it's good enough. So it's not the Copilot agent mode; it's just the completion. It's sometimes useful to write code quickly, right? So I added my so it won't work out of the box because I have to add this, and what I will do is add this off screen because it's a secret key and tokens cost money. So let me add it off screen. So and I'll just show where I'm going to add it so that right. So when I run this, it will fail for sure. So it fails in unauthorized because the key is not there, right? Then I'll edit its configuration, environment variables. I'll say Anthropic API key. The value is, I'll add this off screen. Okay, I've added it and let's try to run and see whether it works. I have to see whether I have credits or I have to create a new key. Okay, it works. So the key is working, right? And it has answered to us what is a quaternion, but yeah, let's not bother us with that. So we have a basic integration with Claude setup. This is like a template code, but this is good enough for now. What we get access to is this client where we can send messages to it. We receive back messages and we can do like parse it for something, right? So in our main file, what we have to keep is the client setup, right? And this new message, we can abstract it out as a function. And we can call that function for now run inference. It's called LLM inference. And I don't know what to return. For now, okay, let's see what this guy returns. Return message, right? What is it saying to the argument? Okay, it needs client. We added client, say argument, and we add Anthropic message as a response. Right, okay. We'll see what to do with this, right? For now, we will put this here. Okay. This looks good. Right, so we have a fun. Let's run this. I think it should work without a problem. Let's not burn tokens for testing simple changes. Uh, yeah. Right, so we have a function an interface. The this text should be input message. Right. What this is. So we can send it whatever. Right. So this is the first order of business. This looks good. Let me see how the stream is going. Okay. Right. What is next is, so this interface we have not yet uh, finalized because we're just sending a text. We should be able to send messages and receive message, right? So that will be the interface, but for now let's keep it that, and we start with another piece, which is the core agent loop, right? Actually, now that I think of it, let's start with as this, right? What is wrong here? Oh, where did we write this? Okay, okay, because of the comma. Okay, so the first thing we need is, right, a system prompt, right? That's what we call a system prompt. So basically it's building some context for the agent to know what it is and how it's starting, right? So that is the first message we will add. Then we will add a user defined goal, right? So that is what we give to the agent, right? And then here just we pass input messages, that as an argument, and we will clear. Okay. Okay. Now we need to define the system prompt. Let constant and let's write something like you are an autonomous agent working in a project repository. I think that is good enough for now. So basically, one of the things we have to do is to tune this prompt so that our agent is better, right? So we'll come to that, but for now, this is the system prompt. Follow the goal. Okay. Below. Okay, just let's introduce the goal, right? And then with this, what we can do is just label that this is the goal. Right. And where we will get the user goal is we will get it from the argument. So let's keep this like command line setup for now. So we need to have arguments. Let's use a flagging library. Right. So goal is, let me refer to the syntax of this goal. Right. Okay. And we need to, because it returns back as a string pointer, so we have to dereference it. All right, so we got the goal from the user, and then we define what the, so before doing anything we have to do flag dot parse, otherwise this will not work. Right. So now let's test this. Okay, how to test it without exposing the key, right? Let me set the key in the environment variable secret. Okay, expose the key. What was this thing? Okay, what are atoms? Let's keep it simple. Unauthorized. Okay, so the key is not reflected here, right? I've set the key off screen. Anyway, the budget in those keys is too low, so it doesn't matter if it leaked, but let's hope it's not leaked during the stream. Okay, what are atoms? Okay, so we have our setup ready that we have a CLI which uses Anthropic's OpenAPI key. It asks for a goal in the params, right? And from that we create a kind of like a input message to our LLM. Currently agent, it's a single inference, it's not an agent yet, but and we just send the messages to Claude and print the response, right? So this is good enough for us to start building the agent loop, right? We have the next 15 minutes remaining, so we can pick up the pace. Right? The agent loop looks something like this, right? It's a forever loop. First thing we do in agent is, let's say, run inference. Right? The second thing we do is if there are tool calls, execute them, append tool result. So, right. So this input messages will be a global variable which we have initialized with system prompt and call. So this will be out of the loop. So we have to run inference with these messages, right? So the response messages will contain something, text like this, right? If it is text, we just have to add back into our messages. If it is a tool call, we have to execute the tool. So I'll come to what tools are in this setup. So broadly, tools are a way for LLM to access its outside environment. So to read it or to take actions on it, right? To perceive it, to take actions on it. So the environment in this context is the repo or the directory in which this agent is initiated, right? So, and the tool that we'll be making in this stream will be to read, to list files in this repo and to, yeah, that's all for now, right? So, and the way LLM, we give this tool to LLM is we just say that this is a tool, this is name, let's say read file, this is a description, and what is this JSON schema for that particular tool to be invoked, right? So what are the input parameters? And so the LLM knows that if it wants to use the tool or if it decides to use the tool to achieve a particular goal, it needs to create an input JSON with that schema, and with that it gives the control back to the agent. So the LLM gives the control to the agent. In our agent code, we can execute the tool, right? So we write the implementation of the tool. We tell to we tell to the LLM what happened. So we append the tool result. So in this case, so for a list file agent, we will give the content of the file, and this is mostly text, right? Yeah, and then we give it to the agents. So in the next iteration, we will run inference with the appended messages list, right? And so the agent will follow the conversation. So this is kind of like a conversational flow, right? Where the first conversation starts here with the user goal, right? Then it will do a bunch of calls. So we have to define these tools, right? And once LLM decides to call a tool, we add the result back and we ask it what is the next steps to, and it will use its reasoning and skills to come up with the next steps, right? So that is what I mean when I say tool calls, right? So let's figure out how tool calls are done in Anthropic. Let's quickly open our tool calling. Okay, so for Anthropic, what is a tool call, right? So we have to declare what tool params are, right? So this is a simple tool description. We have to describe the schema, right? Oh, there is already a for loop for the agent in the sample itself. So we can try to follow it for now, right? Let's not complicate things too much. Right. Okay. So the tool will be doing this and get a read file, right? So let's copy this one here. Space. We already have this stuff. Let's paste it in our. Oh, this is a wrong one. All Windows. Okay. So this is the code tool looks like, right? I have to define this one. So I'll say read file description. Okay, let's first do list files, right? Right. Return a list of files current directory. Okay, we'll see if we want to implement recursively or not. For now, let's just stay here. Right. And how the tool schema is defined is, let's do it here. Let's come back. I'll close. The tool schema is defined in this way, right? So it just instruct, right? So input. Let's not have any. Okay, let's give it directory, right? And I think there's something else. Oh, JSON schema definition is required. Okay. So this is the input that we ask from the LLM, which files you want to read. So path of the directory that they want to read the files from, right? So this description is what goes into the LLM's context of for it to figure out how to populate this field, right? So okay, we need to give it a empty struct for it, is it? Let's figure that out. Empty struct. Okay, this is another thing. Schema. Generate schema. Okay. Right. So we need two things. One is the input struct and its schema version, right? And where does this generate schema thing come from? Okay, generate schema, right? It's a function that use reflection. Okay, makes sense. I'll just quickly walk through what it is. So let me get the JSON schema as well. dependency. So what this generate schema does is gets any type using generics, right? And it will create a instance of the input schema. So it will take this struct and it will try to describe the structure of this, right, into some kind of a JSON schema. So that is that is why the JSON schema reflector is being used, right? So let's get this JSON schema input library. They use this third party JSON schema library. We need to get it from let's do go get here. Okay, it's here now. Does it generate schema work? It needs. Okay. So this is just a boilerplate code currently we're putting in the main file. Later we'll refactor it a little bit to so that it is in its proper place, right? So we have schema. This is our first tool that we describe. Let's input schema, right? So we describe the tool to the agent. Now we need to be able to, these are the tool params. Okay, let's just go here and see this properly, right? What we need, we have messages to tool params. So tools is the first. Get coordinates. Where is the get coordinate function implemented? Get coordinate. Okay. Okay, so they don't have any interface here, right? Okay. Cool. So this is enough for describing what the tool is. So we have the tools. We have to send the tools to the interface logic, right? And then we'll get a tool result. We see what to do with it, right? Okay. I think this is very much close to what we're trying to build right now. So I'll keep this handy for reference here. Right, so we have the tools. We only need to define this one. So this bit belongs outside the loop, right? So let's call this tool definition. Right. We are 1 hour in and we have not completed yet, but let's try to complete this piece of logic. Yeah. So we do run inference, and for run inference, we need to pass tools, right? Tools. Okay. So we are passing the tool. So to the LLM, we are in each inference, we are saying this is my conversation history. These are all the tools available, right? We are using a lot of tokens for now, but it's fine, right? So now the response, we can't just print it directly, right? So what it says is for iterate on the response range as content. Now we need a switch block. So we have to try to figure out what type of block is sent, and is it anthropic text block, so whether the LLM has response with text, right, or whether it has response with tool use block, in which case we have to parse it. Okay, we got the input JSON. What to do with this input, right? Okay, for now let's just print. This is what the document tells us to do, so let's follow it for now. Right, so basically when we do the inference, in the inference, the LLM will either send us a text block, right, which we can just print to our user, or it will send an instruction to tool use, which we are also printing for now, but we have to do something special with this tool use, right? That will do, which is execute. This block is print the response, right? Right. Let's quickly do this now. So, okay. Okay. So what we have to do is we have to add whatever it has given by the LLM back into our chat history, so that when we make the next inference in our agent loop, it can follow along what happened before, right? So that no new context each iteration, it will right. So we just do append to our input messages response star to param, right? So this is how to do it, right? So we add the LLM response to conversation history, right? Then we have to prepare for the tool execution. So like prepare tool result, which should be of type referring to documentation here, content block param union. then what we do is we iterate on this again, iterate on the messages, and skip the part where it is text block. If it is tool block, right, we will execute the tool, right? So the case is okay. If it is tool block, we need a switch on block name. So this is the name of the tool that it will return, right? So if the case is list files, right? Case is list files, we will parse the JSON with direction, directory, parse this, right? Let's just panic. And then we will have a function list file implementation directory, right? So whatever input is, so we are doing a function call, right? So this is the tool that we have to implement, right? And then whatever the response is, let's have this a variable outside of here. Type interface. Now the response is populated. We just have to, okay, we don't need this actually. And let's print the tool response as well, so that we can observe what is happening from logging. And then we need to add the tool results to this result. Just need to result block.id and string of p. Right? So we're giving the result back. What's wrong with this? So it is error. Okay, is error. Let's pass as okay. So now we just have to implement this list tool file function, right? Right. Right. Let's quickly get that out. So what it needs is response interface, can be anything, right? So let's just return string from this file directory. List file response. Okay, let's say output. String for now. Let's keep it simple. So it's just a strings, right? Right. and we need to implement it, right? Let's get so list file, we will just use some go tools to read files, right? Let me get some reference. The function is voice.read dir, right? We just pass the directory here, whatever the entries we get. Okay, and let's return this as well. Return nil. Error reading. So whatever error we get executing, we send it back to the LLM so that it knows what happened, right? So and it can do something else. Then we have prepare files as an array string. Let us iterate through entries. It is a tier. Okay, what to do? Let's do something like this. Name is entry name. If it is tier, name is plus plus add this on front and which is appended. Okay, we have to return a list output. Right, so list file has changed a little bit. Error, right? Right. So if let's have a, so this is tool error actually. Let's call it tool error. Let's see how the string is going. Okay, string is working fine. Right. Okay, where were we? What we were doing is tool error, right? So we have to have a block. So this tool is different. If tool error not equal to nil, we have to it has an error response to the LLM so that it knows. Okay, and what we have to add here is error, tool error, dot error. So this will return a string. We have to tell is error true. Right? But this is how we do it. else we have to tell what happened, right? And this will convert it back into JSON and send it back to the LLMS tool result. Okay, so yeah, we should have our first tool working. If nothing's wrong, we can just test it. Right. We'll go run explain this project, right? So, okay, what is wrong here? Invalid import. Okay, what? Okay, okay, we have something, right? So we already have passed our goal. So it says, I'll help you explain this project, right? It is trying to do list directories. Then it found this, right? Okay. Okay, so it is working, but there's some issue here, right? Let's go through it. There is an error when we send back the tool result to LLMs, right? And oh, I think I know what's wrong, right? We have to add this tool result back into our conversation. Otherwise, it will not know what the result is, right? So what is complaining is that tool use IDs were found without tool result. So we never send back the result and we are expecting a response, right? So this tool result what we have prepared, we have to add it back to input messages like this, right? So okay, so okay, first thing is we have to break this loop, right? If length of tool result is equal to 0, we break from the agent. Basically there's nothing left to do, right? So there's the agent has sent its last text message and it's over. That so this is one way to break the loop. We'll figure out what are the other ways to break the agent loop, right? How to make the LLM give us a signal that this is the end of it instead of just relying on the simple logic, right? Right. Else, what we have to do is we have to append tool result back. Okay, let me see the documentation, see how it is adding the okay, new user message. We have to add it as a user message. I'm not sure why as a user message. Okay. Okay. So we need to add it as a user message because in LLM conversation history, we have to label when we send the history, we have to label what was said by the LLM, right? Which is what they call assistant, and what was said by the user, right? So the tool user in that terminology, a tool result in that terminology becomes a user message, right? Right. So let's see whether this works, right? I think this should be good. So we are testing this tool saying, asking our agent to explain what this project is, right? Okay, so you can already see some agentic behavior here. If you see the logs, right? It says, I'll help you explain this project. Let me explore, right? Okay, it is sending some more versions of it, right? I think we need to take a look into it, like which version to use. Then it does this, right? It comes up with a JSON. It says, I need to explore this directory dot, right? It comes up with this input parameters. Then our tool execution logic, which we have written, will return it this, right? That these are the files in the current directory. Then it says, okay, let me explore these files. Then it goes into Git folder. It explores all the stuff in Git folder. So there's already agentic behavior. It has an exploratory behavior that it has built into when the agent is trained. Oh, sorry, when the LLM is trained. So it already knows it needs more context, right? Now it read the file, it read the IntelliJ IDEA files, right? Right. And based on its finding, it's saying that, okay, based on the file, I can see, let me provide an explanation, right? So it's an overview. This is a Go-based project, right? So this is, I think, a good end to the stream, right? We saw our agent being built, and it's trying to explain to us what we have done so far, right? So I'll just summarize this before I end the stream. So what we have done is we started a Go project, right? The roadmap, we have our future plans, right? And we are building an framework for autonomous agents. So it's a very basic description. I think this is not that useful, but we can already see some agent behavior it using tools, right? And we executing tools on behalf of the agent, and we got our first agent loop working. So I know this is not much to, but I think this is a good start for our project. So we managed to get stuff working. We set up a first agent loop, and we define our own tools, right, which will be used for our further expand our project into giving it more tools, right? So this is very basic, a single page, single file application for now, but we will refactor it soon. Yeah, I think this is good day's work. So let me say, let me see, add this on, and I will say stream 1 basic agent loop with list file tool. So currently we've only built list file. So the description that it had given is only based on what are the files here, right? Currently we have not given it ability to read files, right? Which is what it would we would be doing next, but I think we can do it in the next stream. Okay, let me push original master. If I go to our repo here, we should see our first commit live, and if you want, you can look into it and see how it is, and stay tuned for next streams. Thanks. I think we had a couple of views. Thanks all for joining, and we'll follow this project next Sunday. Thank you, everyone.